Hello everyone, in this video we are going to talk about quadratic graphs. Let us quickly recap. The quadratic function is f(x) equals to ax squared plus bx plus c. When we talk about a function, we usually consider about its graph. So for quadratic function, the graph of y equals to f(x) has a curved shape. That is called a parabola. When we want to sketch the quadratic graphs from the function, we can determine the shape of the graph by some key features. Now let's focus on the key features. The first one, we need to determine the overall shape of the graph. What thing do we need to look to determine it? That is the coefficient of x squared, that is a. In the detail, when a greater than 0, we have upper U, that is a small face. When a less than 0, we have a sad face. When you want to determine the overall shape of the graph, we just need to look at the coefficient of x squared, whether it is greater than 0 or less than 0. Now move on to the second feature. As you can see in the diagram, the curve crosses y-axis and x-axis. So there are some key points over here. Probably 3, probably 2, or none. It depends on the curve. So when the graph let me change the color. Yeah. When the graph crosses y-axis, what has happened? Which means this point over here, right? So cross y-axis, which means x equals to 0, right? X equals 0, and then we have f0 equals to a times 0 squared plus b times 0 plus c. We left c. So the intersection point is is 0c. So here, that is 0c. Now, how about the graph crosses x-axis? So when the graph crosses x-axis, so that is this line, so these 2 points, which means y equals to 0, right? It implies that f(x) equals to 0. We have talked in the previous video, which means you need to find the values of x for which f(x) equals to 0. That is the root of the function. So intersection point. Well, we don't write that. So maybe, let's see, we have the roots of the function. Yeah, the roots of the function. Maybe we can have 0 roots, 1 root, or 2 roots. In here, I just write 2 roots as an example. So in this graph, we have two roots that will be, let's say, the roots of the function, maybe to be right, like x1 and x2. So the intersection point is x1, 0 and x2, 0. So that is x1, 0, x2, 0 here. Now let's move on to the third key feature, talking about the turning point and the line of symmetry. So for any quadratic graph, it has one turning point. In this graph, we can see here is a turning point. Right? To find the turning point, what we need to do to the function. So let's write down to point. What we need to do is to do the completing the square. We need to do the completing the square to the function, and we have the function f(x) equals to a times x plus p squared plus q, and the turning point is at minus pq. Why is that happened? Look at here. We said that x plus p squared greater than and equal to 0. It's always like that for any real numbers. Now we let x plus p squared equals to 0, so x equals to minus p, and f minus p equals to q. That is a turning point. If we have a greater than 0, so that is a small face, we have the minimum point. The turning point is a minimum point. If we have a less than 0, so that is set face, so the turning point is the maximum. Here is a maximum point. Now let's talk about the line of symmetry. To find the line of the symmetry, that is the halfway between the two roots. So the halfway between the two roots, that here is, so that is the line of symmetry. we can see it also passes through the turning point. So we also said the turning point is on the line of the symmetry. Yeah. Let's make it bigger to see. And you see the graph. So those are all features that we used to sketch the graph, to sketch the quadratic function. Now let's do some exercise. First exercise. Yeah. Let's see the question. So it asks you to sketch the graph of y equals to x squared minus fx plus 4, the quadratic function, and find the coordinates of its turning point, and write down the equation of its line symmetry. So in this question, it asks you to do, first, we need to do sketch the graph. Second, find the coordinates of the turning points. Third, the equation of the line symmetry. So let's do it step by step. So to sketch the graph, we need to determine some key features. So the first one is the coefficient of the x squared to determine the overall shape. Let me write. Determine the shape. In here, a equals to 1, that is greater than 0. So it is a small face. So upper U, small face. And also we have talked about if it is a small face, what is a turning point? Here. Let me bigger. Small face, the turning point is a minimum point. And secondly, we need to do is to determine the intersection point. So, cross y-axis, that is when x equals to 0. So y equals to 0 minus 5 times 0 plus 4. So y equals to 4. And we have the point cross y-axis is at 0.804. Then think about crosses x-axis. That is when y equals to 0, implies that y equals to x squared minus 5x plus 4. X squared minus 5x plus 4 equals to 0. So we need to solve the quadratic equation. That is x minus 4 times x minus 1 equals to 0. We get the roots, that is x equals to 4 and x equals to 1. So there are two roots, which means there are two intersection points. Implies that crosses x-axis at 1, 0 and 4, 0. Then move on to the third step. We need to determine the turning point. What we need to do the completing the square. Completing the square. We have x squared minus 5x plus 4 equals to x plus 5x plus 5 over 2 squared minus 5 over 2 squared plus 4. And we have x minus 5 over 2 squared minus 25 over 4 plus 4 equals to x minus 5 over 2 squared minus 9 over 4. This, we have the turning point, which is also the minimum point, is at 5 over 2 minus 9 over 4. Fourthly, we need to find the equation of its line of symmetry. Let's move. So the line of symmetry is vertical. So vertical and goes through the minimum point. That is the turning point. Which line is it? It has the equation x equals to 5 over 2. Look at here, 5 over 2, 5 over 2. Then we can sketch the graph. We have determined all the key features, the shape, the intersection point, the turning point, and the equation of its line of symmetry. Final thing we need to do is to sketch. When the question asks you to sketch the graph, it does not mean you need to be plotted exactly, but you need to draw a smooth curve by hand. So let me write that. What you need to do is to draw a smooth curve by hand. The second thing you need to do is identify any relevant key points. What are they? They are the intersects, that is a point crosses y-axis and x-axis, and the turning point. The third thing is to label your axis. That's what you need to do to sketch the graph. So let's do it. We have the x-axis and y-axis, and here is the origin. So the first thing, from here we determine the shape is a small face. So a small face, and it has two roots, so 2 points crosses x-axis, and where is the point crosses y-axis, that is 0, 4. So 0, 4. So here we write 0, 4. And we also have 2 points cross x-axis that are 0 and 4, 0. So we write here that is 1, 0, 4, 0. Now we need to find the turning points. The turning points are here. And so 5 over 2 minus 9 over 4. So here, that is 5 over 2 minus 9 over 4. Finally, we need to draw the line of the symmetry. So that is a vertical line goes through the minimum point. So that is x equals to 5 over 2. Yeah. That is how to sketch the graph for this question. Have we finished this question? Let us check. So what we done, we sketched the graph. Yeah, we sketch it. Find the coordinates of its turning point. Yeah, we done that. Write down the equation of its line symmetry. Yes, we have done that. So we finished this question. Let me put it over here to quickly see the whole process. Yeah. Now let's move on to the second question. So there is a graph. The graph of y equals to ax squared plus bx plus c has a minimum at 4 minus 1. So minimum point, which means it is a small face, right? So a must greater than 0. And pass through 1, 0. And then the question asks you to find the values of a, b, and c. Now we know that the minimum point. How do we do that? The minimum point. It told us the small face and a greater than 0. And also minimum point is the turning point. When you want to find the turning point, what we need to do, we need to complete in the square. So we have y equals to ax squared plus bx plus c. And we do the completing square, that equals to a times x squared plus b over ax plus c equals to ax squared plus b over ax plus b over 2a square of that minus that bracket plus c. What we get a times x plus b over 2a squared minus b squared over 4a squared bracket plus c equals to a times x plus b over 2a squared plus c minus b squared over 4a. So the turning point is when x plus b over 2a squared equals to 0, which implies that x equals to minus b over 2a. Correspondingly, y is equals to c minus b squared over 4a. We know that the turning point is 4 minus 1, which means x equals to minus b over 2a equals to 4, and y equals to c minus b squared over 4a equals to minus 1. So that is what the minimum point told us. And then we have another precondition that this curve passes through 1, 0 here, which means when you substitute 1, 0 into the function, it works. We have 0, y equals 0 equals to, so ax squared plus bx plus c equals to a plus b plus c. Let's list all the equations we got. So first one, minus b over 2a equals to 4. C minus b squared over 4a equals to minus 1. And a plus b plus c equals to 0. That is all the equations we got so far. Now let's to solve these equations. How do we do that? So we can write from the minus b over 2a equals to 4 what we can get. Let me write over here. Yeah. So we have minus b over 2a equals to 4. To be noticed that a does not equal to 0. Where do we get that? Because it has a minimum point, it has a turning point, so it must greater than 0. It's not equal to 0. So what we can do is to multiply 2a on the both sides. We have minus b equals to 4 times 2a. That is minus b equals to 8a. So b equals to minus 8a. That is what the first equation told us. And then we can substitute b equals to minus 8a into the equation 2. Yeah. So substitute b equals to minus 8a into equation 2. What we have, c minus b squared over 4a equals to minus 1 implies to become c equals to minus 1 plus b squared over 4a, and substitute b, we get minus 1 plus, so minus 8a squared of that over 4a. Thus, minus 1 plus 64a squared over 4a. And we can cancel some of them. So a cancel that. It has left 1. 4 divided that. We have 16. So c equals to minus 1 plus 16a. Now, what we can do, we can substitute B and C into the equation 3. So for the equation 3, we only have one unknown number, that is the A. So we can solve it. Substitute B equals to minus 8A and C equals to minus 1 plus 16A into equation 3. So we have 0 equals to A plus B plus C, right? A plus B plus C implies that 0 equals to A minus 8A minus 1 plus 16A. We get 1 equals to minus 7A plus 16A, that is 9A. So we got A equals to 1 over 9. We check that is greater than 0, so no problem. And we substitute A back to the B and C. We get B equals to minus 8 times 1 over 9 equals to minus 8 over 9. And C equals to minus 1 plus 16 times 1 over 9. We have 7 over 9. So for this function, we have y equals to 1 over 9 x squared minus 8 over 9x plus 7 over 9. So the question asks you to find the values of a, b, and c. So finally, we need to write a conclusion, that is, we have a equals to 1 over 9, b equals to minus 8 over 9, and c equals to 7 over 9. Yeah, that is the whole process for this question. Now let me to scroll down to let you see the whole process. Hope you can see it clearly. If not, you can pause the video at any time to make the notes. So the whole knowledge we have learned in this lesson is just at the beginning of the lesson, that these key features that are really important. You need to remember it. And hope you enjoy watching this video. Thank you.